Hi, algebra students. We're going to continue working with graphing quadratic functions. Today's are going to look a little more complicated, but I'm sure you're up to the challenge. Let me share my screen and start the presentation. And today we're going to start with a little warm up. So you might want to grab a piece of paper and go ahead and try this warm up on paper. So pause the video and give this a try. All right, hopefully when you had a chance to try this, it says for the graph of the quadratic function y equals x squared minus 4, tell whether the graph opens up or down and identify the coordinates of the vertex. All right, let me grab a pen here and we'll go through this. So hopefully you noticed that this is positive, right? The number in front of this x squared is positive, so the graph opens up, right? If it is a positive a term, and we can't see any numbers there, so it's a positive 1. If it's positive, it opens up. It's going this direction. Next question, what are the coordinates of the vertex? Well, if I cover up this minus 4, this looks just like our regular parent function, right? Remember, the parent sits at 0, 0 and opens up this way, right? We have some points in there, 1 to the right, 1 up, 1 to the left, and 1 up. So this is the parent. And if you recall from the last lesson, this minus 4 takes that U shape and it's going to shift it down 4 units. So my vertex is down 1, 2, 3, 4. Again, we still have a point 1 to the right and up 1 and 1 to the left and up 1. But our entire parabola has been shifted down. That's not a very good drawing there. All right, so the coordinates of the vertex should be 0, comma, -4, because we had that downward shift. All right, let's continue and look at what we have today. So today we're going to talk about two terms. We're going to talk about minimums and maximums. If a parabola opens upward, it has a minimum, right? It has a lowest point. If it opens downwards, it has a maximum or a highest point. The y value of that vertex is the maximum or the minimum. So it's if it said what's the maximum value, you'd look at the y coordinate, not the x. All right. Let's look at our next slide. When a quadratic is in what we call standard form, so notice this is a little more complicated. You had lesson 8.1, which just had quadratics just like this. In 8.2, we introduced if we had some sort of shift up or down. Remember, that was our c coordinate. But today we're going to have this middle term. All right, so when we have this ax squared plus bx plus c form, that's called standard form. All right, so I would like you to copy this example into your notes on page 257 when we get there. So hold on. It says, when a quadratic equation is in standard form, the x coordinate of the vertex is -b over 2a. All right. The y coordinate of the vertex is y equals -b over 2a. That shouldn't say y, that should say x. I have to fix that slide. All right. The x coordinate of the vertex is -b over 2a. The equation of the axis of symmetry is x equals, I don't know why I have all these y's in here. Should be x equals -b over 2a. It's a vertical line, a vertical axis of symmetry. All right. The y-intercept is always going to be c, right? Y-intercepts, remember, we get those by putting zeros in for x. So if we put 0 here and 0 here, we're going to end up with just c. So our y-intercept is c, or it's the point 0, comma, c. All right, this next example, you're going to copy into your notes on page 257. All right, so we're going to try one of these. You should see some blank space on 257 on which to copy this. So it says, find the coordinates of the vertex of the parabola y equals 2x squared plus 4x minus 5. So pause your video and write that down, please. All right, welcome back. We are now going to find the x coordinate of the vertex. And the x coordinate, it says, is -b over 2a. Well, let's talk about here, what's our b? So remember, oh, let's go back. I didn't have my pen grabbed there. Okay, what's our b? Remember, if it's in standard form, it's in the form a x squared plus bx plus c. All right, so this is in standard form. So to find the x coordinate of the vertex, we need our a, which in this case is 2, and we're going to need our b, which in this example is a positive 4. So x coordinate of the vertex is going to be -4, because it's negative b, over 2 times our a value, which is 2. So I'm going to go ahead and simplify that. I have -4 over 2 times 2 is 4. -4 divided by 4 is -1. So our vertex so far, we have found the x coordinate. So our vertex is -1 comma something. We don't know the other coordinate. All right. It says step 2, plug your answer from step 1 into the original equation to find the y coordinate. So this is where it can get a little bit tricky. So you need to be careful. So our y coordinate is 2 times whatever our x coordinate is squared plus 4 times our x coordinate minus 5. Remember, you can do all of this on your calculator if you're worried you're going to make a mistake. So the number we are putting in here in place of x in these cases, in each place, is -1. So -1, -1. All right, we're going to do that. Remember, order of operations, exponents comes before multiplication. So -1 to the second power is a positive 1 because it's -1 times -1. So 1 times 2 is 2. 4 times -1 is -4 minus 5. All right, so this is what my y coordinate is going to equal. So I'm going to simplify that. 2 minus 4 would be -2. And if I take 5 more away, I'm going to get -7. All right, 2 minus 4, -2, -2 minus 5, -7. So I now know my vertex. Oh, and it says write it as an ordered pair. I kind of jumped ahead there. So it should be -1, -7. Our x coordinate was -1. We found our y coordinate was -7. And that's our vertex. All right, so when you have it in standard form, again, to find the x coordinate, it's -b over 2a. Take that answer and plug it into the equation for y. All right, let's try some on page 258. All right, the directions on 258 for number 1 say, find the axis of symmetry and the vertex of the graph of the function. So the equation for the axis of symmetry is the same as the x coordinate of the vertex. So I'm going to grab my pen here. And in order to do this, it's in standard form. I need to do -b over 2a. We're going to need to remember this over and over. It's going to come up. So let's figure out what our a and b are in this case. So on number 1, remember a is the value that's in front of the x squared. It's the coefficient. So in this case, our a is 1. Our b in this case, and be careful with your signs, our b is a -10. So if I'm trying to do -b over 2a, I'm going to have a -10, right, over 2 times 1, right? We want to simplify that because we are finding both the equation of the axis of symmetry and the vertex. -10 turns into +10. 2 times 1 is 2. 10 divided by 2 is 5. All right, so our axis of symmetry, and it's a vertical line, so it starts with x equals 5. All right, that 5 is also the x coordinate of our vertex. Do you remember how to find the y coordinate? If you said plug this into the original equation in place of x, you are correct. So our y value, or the value of the function at 5, our y value is going to be 5 squared minus 10 times 5 plus 2. All right, so we're going to do that. 5 squared is 25. Negative 10 times 5 is negative 50. And we're going to add 2 to that. So I'm going to keep simplifying here. 25 minus 50 is a negative 25. And negative 25 plus 2 is negative 23. Right? So that's the y coordinate of our vertex, or the value of the function at 5. So our vertex is, remember, write your x coordinate first. Our x coordinate was 5, way back in that first step. And our y coordinate is negative 23. All right, let's try the next example. All right, in this case, our a is negative 4. And our b is a positive 16. So coordinates of the x coordinate of the vertex, we're going to do negative b over 2a. So negative 16, because it's positive, and that's going to make it negative, over 2 times our a value, which is negative 4. So a numerator, we have negative 16. 2 times negative 4 is negative 8. And negative 16 divided by negative 8 is a positive 2. All right, so we have our x coordinate of our vertex. All right, and that's also the equation for our axis of symmetry. X equals 2. All right, to find the y coordinate of the vertex, remember, plug that x value into the equation in place of x. All right, so here's my original equation. Negative 4 times something squared plus 16 times something, and those somethings are getting filled with a 2. All right, so order of operations, square first. 2 squared is 4. Negative 4 times 4, negative 16. 16 times 2, positive 32. Negative 16 plus 32 is 16. So the y coordinate of our vertex is 16. And we put it all together, and we write that our vertex has the coordinates 2, 16. All right, on number 5, it says graph the function and describe the domain and range. So we're going back a ways here. We haven't talked about domain and range in a long time. So I want to graph this. A couple things I'm going to need. I'm going to need a vertex, and I'm going to need some point on the graph. So let's start with our vertex. Remember, we need negative b over 2a. So our a in this case is positive 3. We get that from here. Our b is a positive 6. So I'm going to do negative b over 2 times a. That's going to be negative 6 divided by 6 is negative 1. All right, so the x coordinate of my vertex is negative 1. I need to plug that negative 1 in place of x into my equation to figure out my y coordinate. So I'm going to do 3 times negative 1 squared plus 6 times negative 1 plus 2. All right, simplify. I get y is equal to negative 1 squared is a positive 1 times 3 is 3. 6 times negative 1 is negative 6 plus 2. And I'm going to keep simplifying. 3 minus 6 is negative 3. Negative 3 plus 2 is negative 1. So my vertex is negative 1, negative 1. All right. This is also positive, so I know my parabola opens up. I have that my vertex is at negative 1, negative 1. So that's my vertex. The other thing I should notice, and I'm going to switch colors here. The other thing I should notice is that the axis of symmetry, remember, always runs through your vertex. It's a vertical line running through the vertex. So I know that's my axis of symmetry. Another easy point on the graph to find is the y-intercept. Remember, the y-intercept is the value you get when you put 0 in for x. So that point would be 0, comma, well, let's see, 3 times 0 squared, that's 0. 6 times 0, 0. 0 plus 0 plus 2 is 2. All right, and that will always be the case that your y-intercept is this constant here at the end, because if I put zeros in these x's, they're going to go away and I'm left with 2. So I know there's a y-intercept at 0, 2. All right, so to graph this, if you remember, an axis of symmetry cuts the graph in half. So if I have this point here on to the right of the axis of symmetry, there must be a mirror image of that point, one space to the left of the axis of symmetry. And that's enough information to graph my parabola. I'm going to draw a curve that goes through both my vertex and those points I found that I know are on the curve. I put arrows on the end indicating that the parabola goes forever. All right, let's try number 6. So we're going to start the process the same way. Step number 1 is always to find your vertex. All right, so in this case, my A is 2, my B is -8. So when I do negative B over 2A, remember that's the x coordinate of the vertex, always negative B over 2A. I'm going to have -8, right? Because it's negative and I already have a negative there, over 2 times 2. So -8 results in a +8. 2 times 2 is 4. 8 divided by 4 is 2. So far we know the x coordinate of our vertex is 2. How do we find the y coordinate? We're going to plug 2 in for these x's. So we're going to have 2 times 2 squared minus 8 times 2 minus 1. All right, I'm going to draw a little arrow here. 2 squared, remember order of operations, 2 squared is 4. 4 times 2 is 8. Minus 8 times 2, 16 minus 1. All right, let's try putting that all together. 8 minus 16 would be -8. -8 minus 1 is -9. All right, so that's my vertex. We also have an axis of symmetry. I'm going to switch colors again. We also have that axis of symmetry that's going to run right through this coordinate, right? It's going to run right through 2. So I'm going to draw in my x and y axis here, and I've got to know that I need to fit a 2, -9. So I'm maybe going to put my my axis up a little bit higher here so I can graph those points. All right, so we have a vertex at 2, -9. So 2 to the right, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, this one is opening up, right? This is positive. Remember the other easy point to find? It's the y-intercept. In this case is at -1. Remember, put in 0 for x. Our y-intercept is here. I'm going to draw my axis of symmetry in red again. Okay, so remember, if this is cutting the graph in half and I have a point 2 places to the left of the axis here, there must be a corresponding point 2 places to the right. So that gives me enough information to draw my parabola. I've got 3 points. That's plenty. So the right side of the parabola goes through from the vertex and goes through the point, looks like 4, -1. And on this side, it goes through 0, -1. Right. So there's our graphs. All right, number 9 says, tell whether the function has a minimum value or maximum value, then find that value. All right, so let's talk about, in order to know whether it has a minimum or a maximum, you need to know if it opens up or down. So we look at this coordinate. This is positive, right? So this graph opens up, which means it has a minimum. It has a lowest value. When you're trying to find that minimum value, it's the y coordinate of your vertex. So we're going to start with our negative b over 2a process again. We're going to take that answer and plug it back in. And that answer we get after we plug in the x coordinate of our vertex is the minimum value. So negative b would be negative 16 in this case, over 2 times a would be 2 times 8. Negative 16 divided by 16 is a negative 1. That's the x coordinate of our vertex, right? Our minimum value is this y coordinate, so we need to find that. So our y coordinate is 8 times negative 1 squared plus 16 times negative 1 minus 2. All right, negative 1 squared is 1. 1 times 8 is 8. 16 times negative 1 is negative 16. Subtract 2. So we get for our y coordinate 8 minus 16, negative 8, negative 8 minus 2, negative 10. So this graph has a minimum, and the minimum value is negative 10. All right, let's look at our next one. Again, the process is the same. We're going to do negative b over 2a. Notice our b is already negative, so we have negative negative 4 over 2 times our a value. Careful here, your a value is negative 1. So we have a negative negative 4 is 4. 2 times negative 1 is negative 2. 4 divided by negative 2 is negative 2. Remember, that's the x coordinate, and we need the y. So I take negative 2, plug it back into the equation in place of x. So y is equal to negative 2 squared minus 4 times negative 2 minus 7. All right, we're going to simplify. Order of operations, negative squared is positive, but this makes it negative 4. Negative 4 times negative 2 is positive 8 at minus 7. So I'm going to keep going. Negative 4 plus 8 is 4. 4 minus 7 is negative 3. All right, so that's my vertex. And now we needed to know, since this is negative, that the graph opens down. So it has a maximum, right? It has a highest point here. And our maximum value in this case is negative 3. Right, notice it's a max, but it's a negative, and that's going to happen sometimes. Alrighty, our next problem says a function h represents the height of a rocket t seconds after its launch. The rocket explodes at its highest point. When does the rocket explode? Well, its highest point is going to be, and notice if you didn't know, a rocket blasts up, yes, but then, let me get my pen here. It goes up, right? It reaches its highest point, and then it wants to come back down. So it's saying, when does it explode, right? It explodes at its highest point. So we're going to have to do negative b over 2a. So we get negative 250 over negative 32. And that's some crazy decimal number. I'll just tell you, I think it's t equals like 7.8 something. And you can do that on your calculator, right? So the rocket explodes 7.8 seconds after launch. All right, and the next question is, at what height does it explode? Well, this is the x coordinate of our vertex, right? That's the negative b over 2a. Define the height at which the rocket explodes. Oh, equals, that should say. I'm going to take my 7.8 seconds and replace t with that. So negative 16 times 7.8 squared plus 250 times 7.8. So I think I already have this done on my calculator. So I'll just work through that here real quick. Yes, it should be. The height is 976.56 feet. And again, you can type this in your calculator to verify it. All right, I think that's our last example. It is. All right, your assignment today is in the book. There's a link to this page on Schoology. If you have any questions, email me. Good luck.